We did it. Welcome. Hello. Hi, everyone. My name is Stefano. We're here at Science World. Thanks for joining us. What a pleasure to have you here virtually. Before I do anything else, I would just like to take a moment to acknowledge that we are here at Science World in Vancouver on the traditional and unceded territory of the Squamish, Musqueam, and Tsleil-Waututh First Nation. And I encourage you to look at the story of the land where you are. Speaking of which, where are you all? I would love to get to know where you're from, and we have a great opportunity here on Slido to do some back and forth throughout this show, and I'm going to encourage that wholeheartedly. Let's start with going into Slido and entering in the chat where you are listening and tuning in from, and I would love to do some shout outs to all you fantastic folks out there. So you guys start on that, and I'll start on some of the show stuff. Before we go anywhere, I want to tell you that this show today is called The Science Surprises Show, and my name is Stefano. Science World, all those things are going to hopefully roll in together with some fun for the next 20 or so minutes. Now, I've got a few folks with me today, live in person, and we always make sure safety is number one here at Science World. We usually have a nice safety zone in front of the building, in front of the stage rather, and we have done that with you by placing you comfortably in your homes. So you're doing a great job so far. Good job. Here in our building, we've got Brian on camera, and we've got Jeff on computers. Hi, Brian. Hi, Jeff. They're keeping physically distanced from ourselves, and Brian can zoom in when necessary. Hey, Brian, give me a zoom in. Nice job, Brian. That's the logo. And again, encouraging you to tell us where you're from so that we can enjoy that. Part of being here today to celebrate you and all you've done and all the fantastic science that you guys have all explored is also want to say a thank you to one of the associations groups that have helped us be here today, and that is Windsor Plywood. Without their help, it would be a little trickier for us to make this happen. They actually make it possible for us to get all over the province with things like the On the Road school touring program and community science celebrations that we've occasionally bumped into you folks at, which we love. So we were hoping to be able to do that more into the future and not just do this virtually, but that's what we're doing today, and I'm pretty stoked about it. Who here is excited about some science? Pretty sure that's a rhetorical question. That's you guys. So I am as well. What I've decided to do for the Science Surprises show is to frame it around the weather, because it's something that unites us all. We all take vested interest in it, and of course it affects us all, and sometimes differently. And you've done some fantastic projects. In fact, I want to do some shout outs right now. Marin did a great one about the girl who harnessed the wind, Sahil, Solar City, Regan, Silver Lining of Hurricanes. These are some fantastic projects, weather-based, so I thought I'd just roll with that. Sajan, air pollution, Jasmine, cloud chamber, Lucy, shuttering out the storm, Emery, here comes the sun, and more. So great on you for that, and some amazing projects that I've had a chance. I'm noticing here on the chat that we have some folks that are chiming in on where they're from. Brian, who we got?
We got people from Prince George.
Prince George? I've been to Prince George. It's a lovely place. Thank you for joining us from Prince George. Multiple people, I assume, yeah?
Central Interior represented.
The Central Interior, some lovely spots through there. Lovely country. I think some beautiful places out that way. 100 Mile House, I'm sure. We love it. We love it. Anywhere else? All right, I want the rest of you to chime in anytime you want. You can interrupt on the chat, and Brian will just roll with the punches with the show. I will also be asking for some participation and questions throughout the show. So if you have ideas, suggestions, answers to my questions, put them in there. Got it? Deal. Where were we? Yes, the weather. So the weather is a pretty fun thing and a beautiful thing, and sometimes a very big and dangerous thing. So there are three major factors that influence the weather. And I'm sure a lot of you know this, but it's good to cover the bases off the top. And that would be the atmosphere, the bubble of air around our Earth. So that's where the weather happens, and what happens with that air around the Earth is part of one of those factors. The sun's heat, the heat of the sun, so heat, temperature affects the weather, and water. H2O, water is a big, big influencer of the weather. In fact, it mostly makes most weather that we get in Vancouver, in fact. And other places around the province. So I thought I would start with a demo about the water cycle, if that's great with everybody. If we'll start with that, and then you guys please challenge me by sending your suggestion of your favorite or most extreme or most interesting weather pattern And I will do my best to bring you a demo from the gear that I have set up. Fingers crossed I can succeed at this. Brian, there's something on the chat.
We have people from Surrey, from Smithers, and someone from Taiwan, where it is currently 3:30 in the morning.
Well, welcome folks from Surrey, from Smithers, and from Taiwan. 3:30 in the morning. You really have a commitment to science to be up at this hour. Nice job. All right, well, keep those coming, and we'll check in with you as it goes. And thanks for joining us from all over the world. So here we go, water cycle. A lot of us know this. We've learned this early in our science education, just at elementary school level, and that's great. But it's just good to go over some of the basics. So water comes in many forms. Liquid form is the most common. We call it water. In other forms, we call it other things. And I'm just going to pour some water into this cup, and you'll see that I have water. Water. Water moves around the atmosphere on the planet, and that's different words happen for that. You know what they are. We're going to cover them right now just to make sure we're all on the same page. So water starts in a cloud, or let's start it on the ground. Let's maybe in the ocean, and it evaporates with the heat of the sun, goes up into a cloud. It forms water droplets. And then at some point, it's too much, decides to fall. Gravity comes down to the ground. And there it is, rain. This would be pretty heavy rain if that was coming down like that. But that does happen. And then it goes down the mountains. The precipitation goes down the energy of the gravity pulling it down back to the ocean. So the precipitation, the evaporation, the condensation, that's sort of the water cycle. And it just goes over and over and over. So it goes down the mountain, into the ocean, and then back up, evaporates into the clouds again, and then just kind of comes down again. It doesn't always, okay. So hang on. It doesn't always happen so fast and smooth as that, as you know. Like I said earlier, heat, temperature does affect the weather. If sometimes, by chance, the temperature is different up in the clouds or on the way between the top and the bottom of the atmosphere, water can change form, and it can take up different forms such as ice or snow or hail. And we can see that right here as a model. Now, that's not rain, nor is it snow. I just did a little bit of a science trick, I guess. I used some science in here in this cup to create a slightly different texture on this water. There was a chemical called sodium polyacrylate that I put inside this cup, which basically absorbed the water, creating a bit more of a slushy ball. So this is my little version of a snowball. This is, in fact, some science that we've all done, believe it or not, because this chemical is actually in the article of clothing that many of us wear as babies that absorbs baby liquids. It's called sodium polyacrylate, and yes, it is in diapers. And so there we go. I've got gross diaper insides in my hand. No, it's clean. It's good. So I'm wondering if anybody has suggested yet another favorite weather demo or anything like that I can just roll with and jump to. Otherwise, I'm just going to go to some of my favorite go-tos and talk about the different types of weather that I like. So rain, I know you think, why do you like rain so much? But I love to think about rain as this. Some people say it's a gray day, it's overcast, it's ugly, it's rainy, especially for those of you in the rainier parts of our province, like Vancouver and Surrey and other places. Think of it this way. You don't get the green without the gray. A little positive energy for you today. Brian, any suggestions for other weather patterns? We got folks from Vancouver Island, and Brian's sending a shout out to the folks out there because he's from out there too. Well, thanks for joining us from Vancouver Island. When I travel to Vancouver Island, one of the things I notice very often is that I get on the ferry and it's very windy because, of course, the wind is channeled through the Georgia Strait from Vancouver to Vancouver Island. And wind is a really big weather pattern that I find very fascinating, as many of you did too in your projects that I noticed. You can harness that energy from the wind. Wind is air that is moving quickly, usually based on the heating by the sun or other sources of the air. And as hot air rises, of course, it creates a space that cold air fills. And so those hot and cold airs, hot and cold fronts, you hear about it on the news all the time, hot front or warm front coming in, cold front coming in. That's the wind. So I thought I'd do a quick demo with the wind, with this lovely wind-making device. You may call it a leaf blower, and you may know it as a device that blows the leaves onto your neighbor's lawn. I like to use it as a wind-making device. So I just turn this on, and it creates wind. And sorry. creates wind, as I was saying. Wind is very powerful, and now my hair's a mess, but that's okay. This is very interesting because you can create wind on and off, but wind does not do that. But we can harness it and use it in wonderful ways, much like in your projects that I've noticed. In fact, I'm going to use it for a really fun demonstration here. I'm going to try to levitate this ball with the wind. As you notice, summer is a great time to fly a kite, and you can use that wind to keep that kite flying up in the air. I'm going to try to keep this beach ball flying up in the air. I want you to observe what's going on, and if you have any ideas of the principle at play, I'd love for you to put it in the chat. The principle at play that's keeping this ball levitated above the stream of fast-moving air. Here you go. Ready? You might want to mute your microphones if that was too loud the first time around. Here we go. Boom. Ta-da! Anybody put the Bernoulli Principle in there? Because if you did, big thumbs up from me.
Got a lot of weather patterns people are like.
Ah, the weather patterns are coming in. I'm glad. It's just like it's just waiting for that weather. We do that every day. What was happening there? Fast-moving air was moving up, holding that balloon in place, even when it was on an angle, because there was a pocket of air. It's called the Bernoulli Principle. If you want to know more or study or explore more about air, check out our scienceworld.ca resources page. We've got some great demos there for that. And so the wind, it pushes things around. So we can use it to fly kites, we can use it to power turbines, we can use it to all kinds of ways, in all kinds of ways. Brian, what are some science weathery things?
You've got people who like the sun.
The sun!
Yeah. You've got people who like the rain.
The rain, thanks, I checked that off, that's great.
Snow.
Snow, we did a little bit of that, that's lovely.
I'll let them know if they want to include their names, they can put that in there too.
Awesome. If you want me to do a specific shout out about one of the things that you're suggesting, say, Stefano says, I love the sun. And I'll say, thanks, Stefano, for loving the sun. Speaking of sun, I'm going to take that suggestion next because I did a little bit of rain already. So with that, the sun creates the heat. Heat generally is created by three things. Fire is usually created by three things. We call it the fire triangle. So now is a great time into the chat to enter the things that make up the fire triangle while I go on with this demonstration. Now, I'm not going to be able to bring the sun directly here into Science World because it is a flaming ball of nuclear energy that does not actually burn like normal fire, and also it's too big and too hot. So what I will do is I will create a model, smaller model, some fire, and using the fire triangle right here in my hand. So I'm going to do that. To do that, of course, I'm a trained adult, and I'm going to use my proper safety mechanisms, such as my goggles, my knowledge, my fire extinguisher, should I need it, and other various accoutrements around me, such as my baking soda here, my fire retardant blanket, etc. So I'm being very safe with fire. If anybody's giving me anything on the fire triangle, otherwise I'm just going to let you know that you need heat, you need oxygen, and you need a fuel. Those three things make the fire triangle. You take one of those things away, no longer a triangle, no longer fire. So what I'm going to do is I'm going to create some fire with, in my hand with a fuel, which I have conveniently placed far away over here. There it is. This is called lycopodium powder. It is a spore of a moss, and it is highly flammable. So, to that end, I want to place it on my hand. Now, many of you may be thinking at home, I'm glad I'm at home and not at Science World, because he just said he's placing a highly flammable substance on his hand. So I'm being safe at more than 6 feet distance. So what I'm going to do is explain a little bit of what's happening here. We've got our fuel, highly flammable, and I'm just going to add heat to it. So I'm going to add it with my lighter, which I've placed here. Here we go. I'm going to come right in close. If you think this is a good idea, put it in the chat. If you think this is a bad idea, put it in the chat. If you think this is a terrible idea, but you really want to see it anyway, put it in the chat. Here we go. I'm going to add heat to my fuel. There's oxygen in here at Science World, so hopefully you'll see a fireball in my hand, and hopefully I will not get burned. Here we go. Ready? So did I lie? Did I make a mistake? Making mistakes and creating hypotheses for why things are working. There's a tiny little flame happening right there. I'm just going to put it out. A little bit of smoke. So sometimes I'm sure you've discovered this in your research practices, endeavors, especially with these science projects, that the first time you try something, it doesn't work out. Well, I want to encourage you to keep trying, because making mistakes or figuring out why something doesn't quite work is very important to science. There's no such thing as a mistake. It's an opportunity to learn, because knowing that something doesn't work is part of the equation. And I know you know that, but I just want to encourage how great that is for you to do that. So what's missing from this equation is the oxygen. Though it is here in the room, it is not between the thin particles of this lycopodium powder. So what I need to do is spread out the powder so that air and oxygen can get inside. I will do that by moving my hand quickly and hoping that this works and creates a beautiful fireball. If it works, I will hope for some respect, some appreciation on the chat. Would be nice. All right, I need to light it with my lighter, which I've conveniently put out of range. There we go. Fire extinguisher, goggles, ponytail, we're good. Ponytail's still there, right? Yeah, good. All right, now I'm going to spread out the fire, making the three elements of the fire triangle come together. Here we go. Ready, set. Move this one here. Let me get this one. Fire! Thank you very much. Thank you very much. Now, the reason that didn't burn my hand, if you're out there wondering, is because the fire didn't happen on my hand. It happened in front and near my hand. So that's why it was safe, and that's why I didn't get hurt, and that's why I kind of look like Super Mario when he eats the flowers in the 8-bit version. All right.
More people visiting us.
Who is visiting us, and where are they visiting us from?
Someone says they're in Russia, but they also have a wink emoji, so that's really
Russia, but with a wink emoji. I am so perplexed, but I'm glad we've got fantastic folks joining us, potentially with a wink emoji, from Russia.
We have Emery from Fort St. John.
Emery, are you Emery that did Here Comes the Sun from Fort St. John? Because if you are, that's fantastic.
Emery's interested in hail.
Oh, Emery was wanting to know about hail.
Someone else was pointing out the Bernoulli Principle you were doing before also comes up with aerodynamics.
Wonderful. I'm loving the stuff that you guys are putting in the chat. I want to encourage that also because it's stuff that you guys can communicate with each other about all the stuff that you know, and I encourage that because the stuff that you're doing today, yesterday, tomorrow is the science world of today, yesterday, and tomorrow. You guys are it. You guys are the future. I want to say what a great job you're doing. About hail, I just want to address that I don't have too much time in today's show to break down the difference. But when the temperature is different up in the sky, that's going to affect how the water changes state from liquid to gas to solid. And I encourage you to look some of that up. There's so much out there. Or to look to one of your mentors. But thank you for being excited about hail. It's fascinating. Yes, Brian?
People interested in thunder and lightning.
I'm so glad you brought up thunder and lightning. So thunder and lightning is one of my favorite types of weather because it's so dramatic. So up in the clouds, you've got all these particles of dust, and you've got clouds building up a static charge. Basically, static electricity gets built up in the upper layers of the atmosphere in these clouds, and things are rubbing together, much like when you rub a balloon on your head, and it creates static. It's electrons moving around, because an electron is obviously going around the atom, and they can move from thing to thing. So when you have too many and the electrical charge is too great, electrons wanting to repel go down to the Earth and spread out onto the Earth because that's the largest thing they can spread out on. Thing is this, I would like to postpone doing a demo about this till 2:20 p.m. And you're like, Stefano, this is going to be done by then. Here's the deal. At 2:20 today, we're very coincidentally, we're going to be doing a Facebook live stream on Science World CA's Facebook page. And Brian Anderson, this gentleman right here, is going to be doing the electricity show. And we're going to be joined by our partners at BC Hydro. So we're going to do some electricity demos at that show. And we would use the static electric, Van de Graaff static electric generator for that demo. And so I encourage you to watch that. And if you can't watch it today at 2:20, just check back with our website, our YouTube channel, or our Facebook page a little later. And that show will also be there for you to watch and explore that thunder and lightning. But I want to tell you one really cool thing. With thunder and lightning, that sound you hear, so the electrical energy of going from the clouds down to the Earth, we've got sound energy and light energy. And what's kind of happening there is that when the electricity is going through the air, it's ripping air molecules apart and snapping them back together. And if you can do that at home, you just rip it open and snap it back together. You hear a snap crack like that. But when you multiply that by how big and how many air molecules are happening in a thunderstorm, that's that that you're hearing. And also the really cool thing is that sound travels differently at different speeds than light. That's why you never see those two things happening at the same time. You can measure sort of how far away a lightning storm is by the timed difference between the lightning strike and the thunder roll. Cool stuff there, cool stuff. Awesome. Anything else, Brian, or should I just kind of jump to a next demo? Awesome. I got something cool to show you. I'm dying to show you. In those clouds with thunder and lightning, we've got clouds. That's sort of the key point for a lot of this. Again, water is present as water vapor in our atmosphere constantly. It just moves around our atmosphere, right? So I'm going to actually create a cloud in this bottle right here. I'm just going to create a little atmosphere here. I'm going to change the pressure and temperature very quickly, creating an inversion, creating a chance for those droplets of water to get trapped into a cloud. And then hopefully that will succeed, because it doesn't always work, but hopefully. Fingers crossed. Cross your fingers for me. I'm going to need my bicycle pump. And this is something theoretically you could try at home. It works with water, but it's tricky because you're going to want to wear all your safety precautions like your goggles, because you're going to be increasing the pressure inside this bottle. So here's what I'm going to do. I'm going to put my goggles on. And because, of course, I'm increasing the pressure, I don't want this bottle to explode. So I've got my pump, and I've got some liquids in here already. I've got some isopropanol, which evaporates a little faster. I'm going to try it once as is, and if I need to add more, I will. I want you to just watch very carefully here as here we go. I'm just going to zoom in a little bit. As I increase the pressure, which happens, of course, as you go to different levels in our atmosphere, what's inside the bottle, which is air, is going to be affected differently. And when I release it quickly, the air will rush in. There'll be molecules will be rubbing together and creating a very poor cloud. All right, let's try that again. I'm going to add some more isopropyl. Hi, Harold. How are you doing? I hope you're enjoying the show so far.
Harold is joining us from Canada.
Harold, you came all the way from Canada? Nice. You really went the distance for us here today. I mean, really, theoretically, we got Russia, Taiwan, was it? And Canada. This is an international event. So I'm actually just shaking up some of the isopropyl so it evaporates better, and it gives an opportunity for the dust particles that are naturally present in the air to kind of attach to themselves to something. Here we go. We're going to create a cloud in a bottle, I hope. Come on, come on. 1, 2, 3, 4, 5, 6, 7. There it is. There's my cloud. I shall name him Harold, after Harold from Canada. Harold, you are trapped in my bottle. No, let me out. No, Harold, you will always be here. You are ever present, as water vapor is ever present in our atmosphere. But I don't want to be in the show. I'm very nervous. It's okay, Harold. I have a way. You can hide. You can hide. I'm going to change the pressure and make you disappear. Are you ready, Harold? I'm ready. It makes you regret that you put your name in the chat, isn't it? All right, here we go. I'm going to pump it, and you just watch. I'm going to do it this way. Ready? Oh, Harold's disappearing. So as I increase the pressure, sort of changing the state of that water vapor, and then I can bring them back. Harold, you're ever present here at Science World. Oh, neat. Getting some fun fog coming out of here. Fog is actually just clouds, but in the fall, when there's a change in temperature, it's just there in the morning, and then the sun comes in, heats it up, changes it, goes back hiding up in the stars. Clouds, wherever you want it to be. Brian says there's some more things happening in the chat. I would like to know what's going down.
We had someone who was interested in tornadoes.
Tornadoes, you say? Ooh, my favorite. Okay. How much time do we have left? Jeff, Brian? Hello?
5 minutes.
5 minutes? All right. Here's the deal. Tornadoes is one of my favorites. So I'm going to take the cloud demo we just did and transition my way to tornadoes and see if we can do sort of like a big old-fashioned linked weather things, because this is the thing. All the weather is tied together. One thing affects the other, affects the other, affects the other. So that effect of having one piece of weather being, unique in itself, it's not. One thing affects the other. So wind uses clouds. The clouds hold water, creates the rain. We've got tornadoes. So if it works, I'm just going to, yes, it works. Just going to get some air. So my cloud in the bottle, Harold is doing just fine over here. but I've got a fog machine because I'm going to need a little bit more cloud here. So I've used a run-of-the-mill special effects fog machine that is just harmless car exhaust. I'm kidding. And here's what I'm going to do. I have filled this air cannon with this fog. I would like to shoot it at you. So just cover yourselves. Here we go. I'm going to shoot some air at you. You're going to see what happens. When I pull back this lever, it pulls the air in, and then here we go. Nope, that didn't work. There we go. That's what I'm looking for. That is what I'm looking for. You guys see that? All right, I'll do it one more time. So what's happening here is our fog is moving in a fun, fancy way. Now, you mentioned tornadoes, and they go spinning circles and circles and round. That's the science way to say it. And here's what I'm going to show you again one more time. I'm just going to check that out. Boom. 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 So if you see the shape that is. Now, if you know what that shape is, please put it in Slido in the chat because I want to hear it. Now, some of you may say circle. Some of you may say disc. Some of you may say donut, which is my favorite. And some of you may say toroidal vortex. If you look very carefully, it's actually turning in a circle, but it's turning in on itself, a vortex, and toroid being the disc, the donut shape. So toroidal vortex is the name of how that air moves. And air tends to travel in the easiest way possible. So it wants to, not to be lazy, but just to be efficient, travel in the easiest way possible. So when these winds come together or they come through an air cannon, it's just going to move in a natural way. I'm going to do a quick demo here and see if it works. I'm going to try to see if I can make it go square. There we go. I'm going to make a square opening on the end of this. You can see that. There's my square opening. And circle. There you go. So that's not working. So even though it's coming out of a square opening, air is still traveling in a circle. Now that's not tornado. It's not, although it is turning in circles like a similar type shape as a tornado would. So shall we get on to the tornadoes? Nobody? Nobody? Oh, you're at home. Yes. Okay. Let's get to tornadoes. Let's clear the air first a little bit. It's gonna. I should just use the science I have at my fingertips here. I should just do the old. There we go. We're good. All right. So we wanted tornadoes. Right now is a great time to put in the chat what things do you see in a tornado? Describe the tornado. What are the elements of description? What is in a tornado? What is in it? It's wind that's moving, but we see something. So what are we seeing? What are we seeing in a tornado? Put that in Slido, please. I'm going to get my stuff together here, and I'm going to need some protective equipment again. Because what I'm going to do is I've got this great little platform here that spins. Tornadoes are moving air in a circular method or motion when, of course, warm and cold air come together and they meet, and the warm air rises and therefore pulling up and turning. So here I'm going to turn some air here with this turntable. It's just an invisible tornado, which you may not be impressed with whatsoever. Okay. So that's not really that interesting. That's why I'm asking you for what's in it, because I need to put something in it. So while I'm waiting for those responses, I'm going to put something in it myself. I am going to put fire in my tornado. That's a good idea, right? Now, fire tornado is not traditionally a type of weather pattern we see every day, thankfully. But that's the punctuation with the fog machine back there. I swear it was a fog machine. And what you may know, though, especially for those of you joining us in Prince George, that fire tornadoes are very serious in places where there is high forestation and forest fires. Because a fire tornado is sort of a weather pattern that can happen sometimes within a forest fire. In fact, there's some amazing videos online of very brave firefighters trying to put out a fire tornado, and it's pretty humbling, to say the least. So a fire tornado is very powerful. It's moving in a circle, and it's always drawing up more air, and that air fuels the fire. It creates more better burning fire by adding air. So it's tricky. So thank you for those firefighters who are out doing that work. What I'm going to do is I'm going to light this on fire. I'm going to turn the table, and I've got some answers from folks in the chat before I do this I've got something to say, so I'm going to check in with that. And then we're going to see a fire tornado. Now, what are some of the things that folks are telling me on the chat, Brian?
In a tornado, you will find air.
You will find air. Very well said. Cars. Yes, a car in a tornado means that is, stay away. That is a strong tornado. In fact, yes, it's strong enough to pick up objects such as cars. Cows. My heart goes out to the cows. The farmers and the firefighters really got to work together here because make sure to keep them grounded, right?
Someone else has said you will find stuff.
Stuff. Very good. Stuff is very common. Stuff, specifically dust and particles like dirt and dust that are getting picked up. That's often why tornadoes are sort of gray or brown. It's picking up dust. So you see a gray or brown spotted with cars and cows is what you're going to see. And today's is going to be fire. I should probably turn off that fog machine. It's good. All right. Ready for a fire tornado? Here we go. I've got my goggles on. I've got my baking soda to potentially put out my fire if need be. I've got all my safety things and precautions. Everything's nice and clear so you can see my stage. Here we go. Fire gloves on. Turning on my fire with my lighter, which I have placed somewhere. There's the things. I have a good workshop here. All right. Okay, ready? Fire. Fire. We need to zoom in, Brian. We need to get in here. We've got to see the drama. Thank you. So kind. We got fire and fire tornado. Not the fire tornado I was hoping for. All right, let's try again. Let's remove one of the elements of the fire triangle, and that would be removing the oxygen. Therefore, no more fire. Just note, that was a liquid fuel, so I would not want to pour water on it, because when you do that, that fuel would float on the water, creating a fire lake. We're looking for a fire tornado. Why didn't that work? I know I can ask you, and I'm hoping you can get those chats in really fast, how I can make that better, how I can make this fire tornado actually look more like a fire tornado rather than a fire turning on a record player situation. I'm hoping for that. So while you tell me ways that you think, all your great minds at work, I can make this work better, I'm going to say a couple last words and thank a few people while I wait for those answers. Now, all the mentors, all the participants, all the organizers for the science fairs, all the folks at the Science Fair Foundation work very hard, especially at this time currently where it's really tricky and doing this virtually. So a really big thanks to all of you for participating, for making it possible, and it's just great. I just want to say how proud we are at Science World to be able to be a part of this closing ceremonies, and we hope that you've really enjoyed yourselves today, and we hope that you watch this later and go use this as a launch pad today as a launch pad to go forward and do stuff. In fact, I wanted to say to Emily, our MC, our fantastic MC, congratulations on your admission to UBC Medicine. That's fantastic. Here we are today doing this, and tomorrow we're going to be doing more great things. So thank you to all of you. And also thank you to people that are making this possible throughout the year, and that includes people like Windsor Plywood that are helping us be here today and generally around the province. And also to folks like BC Hydro, which is going to be a partner with the electricity show that, if you remember, you're going to watch at 2:20 today on the Facebook stream, because there's going to be some answers to and some demos around the electricity, thunder, and lightning. So just lots of love all around. Now that I've said that, I would like to know if anybody has any solutions for me, because sometimes you're making a demonstration and you want to make it actually good, not just interesting.
Someone has a suggestion, put the fire all over the disc, not just in the little thing in the middle.
Great suggestion. So that's my only suggestion. I want to cover them all at the same time. That's all I got? All right. The suggestion, of course, was to put the fire all over the place, not just in the middle. This would create a situation where we have a larger version of this fire that is spinning in a circle. But I like where you're going with this. You're wanting to spread it out this way, and I want to spread it out this way. And instead of using the fuel to spread it out this way, I'm going to try to use the air, the other element that we're dealing with weather, to bring it up this way. To do that, I'm going to take this cage and place it on top. When I do that, oh, Brian said something. I think he had a chuckle. Something funny got said. What is it?
Well, there's two actually. Spin faster.
Spin faster. Great.
Add some pigs and cows.
I love you all. I love you all so much. I love it. Add some pigs and cows. I wish I had pigs and at least models of pigs and cows to add to this. Would be very entertaining. I might have to look at that for future demonstrations. So spin it faster. I can do that. So we can test that out. I'm all about testing theories when they are safe. Adding more out this way, I don't feel safe about that today. Having never tried that before. So I'm not going to try that one just today yet. But I can spin it faster. Let's do this again. Starting on my fire. Thank you for that suggestion. We got fire, spinning, faster. It's a good suggestion. Not too much of a difference in our success factor with the specific fire tornado goal in mind. Again, putting out my fire, safety first. Do not need to accidentally do one of these. All right. Spinning it faster did something. It's moved the fire in a circle faster, but we're just moving the physical fire. What we need to do is move the air around it, because those three things coming together, the air, the fuel, and the heat, need to join. And wind, that we mentioned earlier, that was in the clouds, which is all over the atmosphere, which is part of the weather, is gonna help us. This cage will trap some of that air inside. It will spin it in a circle, creating a bit more of a confined area, and therefore, and also drawing in some air this way with high and low pressure happening. So hopefully, big finale here, we're going to get a fire tornado. Now's the chance if you have any questions about the show or stuff that has come up prior up to now, to put them in the chat. So as soon as this demo is over, I'm going to take a couple questions if you have them, and if not, I'm going to send you back to Emily to do a final wrap up. So don't go anywhere, even though this is going to be the coolest thing in the next, within the last 5 minutes at least. All right, here we go. Fire, gonna fuel. We had in there. The fire, spinning here. Gonna put this thing on top, makes it safe, and then ready, set, zoom. Oh, nice zoom in. Yeah, that'll be good, Brian. Ladies and gentlemen, it's an honor to be presenting for you my fire tornado. Fire tornado. So what's happening here is the air's coming in, it's joining, it's being lifted up, it's warming up that air, and it's getting bigger and bigger, and it's just beautiful. Of course, we want to be nice and safe and not run it too long, because also you have things to do today. So thank you very much, everyone, for your participation in this today. I would like to leave you with a candle of inspiration, burning constantly. Never quit. Keep doing what you're doing, because you are the scientists of yesterday, today, and tomorrow, and I really, really hope we get to run into each other in the future. Now, any questions?
Yeah, so I was wondering, how do you get high and low pressure for the tornado?
How do I get high and low pressure for the tornado? Great question. So in the natural spinning motion of that tornado, with the air trapped inside here, what's happening is that it's spinning the air that's already trapped in it. That air is being warmed up by the flame, therefore rising, therefore creating space at the bottom of the fire base for regular cold air that's just in the building to enter through this cage. Because if this was a closed circuit, so if this was not a cage, it wouldn't work the same way. So we've kind of constantly got a flow of air coming in. Same principle in a campfire, where you leave a little bit of space at the bottom of your teepee when you're making a campfire or whatever structure you use, so the air can flow in and give more efficiency to that fire. I hope I answered that right.
A couple of comments. You're awesome, great scientist. We're so proud of your tornado. And one final suggestion for how you could have made the fire tornado: Photoshop.
You guys are the best. Thank you for the compliments, and thank you for the suggestion of photoshopping my fire tornado. It's true. Virtually, this could all be special effects. It's just CGI, folks. I'm kidding. It's not. It's just Science World fun. And we really hope to get together with you here at Science World in the near future and all around the province with our outreach programs. Keep doing what you're doing. Really, thank you. It's so inspiring. Your projects are amazing. Emily, I'm passing it back to you. Enjoy. Take care of these great folks. And thank you so much for including us in your day.
Thank you guys so much. Just a huge shout out and a huge thank you to Science World for all of their support, to Stefano and Brian and Jeff. You guys put on an incredible show. Thank you so much. It was amazing. I myself was blown away by your fire tornado. They're right. You did look very, very proud of it. So just some final remarks, just some final notes. I'm going to share my last slide of my award presentation. Oh my goodness. Thank you guys. Thank you for coming. Thank you for participating. Thank you for working on your projects and being amazing scientists. We are so, so excited to see you guys next year at GVRSF in person, hopefully. And I just want to say congratulations. Thank you so much. Feel free to reach out. We're always here to answer questions and continue to support you guys throughout your scientific journey. As they said, don't stop. Don't stop exploring. Don't stop your science. Don't stop going. You guys are amazing, and you guys are going to go into some really, really cool fields, and I'm so excited to see where all of you guys go in the end. So, one last time, thank you guys, and congratulations to everybody. Having great, great summer, and hopefully see you next year. Congratulations, guys. Bye.